Okay. All right. So the option that we did not deal with is, let's say that I have 2 points, and one of the points is not going to be on my y-axis. Let's say I have 2 points where my point doesn't represent some type of like starting period. In this case, let's say I have the points 20, comma, what was my 2 points? 20, comma 7,000. Let's say I have 20, comma 7,000. And I have the point 30, comma 16,000. So if I graph these 2 points, I have one there, I have one up here. Still have my asymptote right there. Okay. So in this case, there is another easy way to compute your little a value that's a little bit different than what we did. And I kind of like compiled it all together. If you're curious about the theory behind it, I would love to show you the theory behind it. But here's what you do. If you have 2 points, x1, comma y1, and x2, comma y2, you can check to see what your amplitude, or your base is rather, by doing the following formula. Take your y's and divide them. So I would take like 16,000 divided by 7,000 in this case. You'd raise it to the 1 over x2 minus x1 power. So if I put this into application, really not that bad, I'm plugging and chugging. I'm going to take 16,000 divided by 7,000 raised to the 1 over 30 minus 20, which is 10. And that will give me an a value that represents how fast my equation is growing. So if I do this problem, that's 116 divided by 7, which is some number, I don't know, some decimal. So this is equivalent to 16 over 7 raised to the 1 over 10 power. If I put that into a calculator, I get 1.09. So if you have any notes, you can check it if you're doing it in a calculator. I get 1.09 for my value. So that's another way of calculating things. Let's say you don't have a starting point that represents the starting population of your country kind of thing. Mm-hmm. That's more the method you're going to want to go with, because that's 2 points that take into account you not knowing the starting population of your country.
So if like I start with this like 1960, what you supposed to find out when you're